Hello, wonderful people of the internet. Welcome back to another episode of Simulaos. Jerry Licious, Sir Komodo, thank you guys so much for coming in. Okay, so I guess today we're going to be working on, I know I wrote down more algorithm archive stuff, but in principle we could be doing a number of different things. We need to be working on some form of animations. We need to be looking over the FFT chapter. We're going to see what kind of makes the most sense, and we're going to go from there. I hope you guys are having a wonderful day, and please feel free to say whatever you want in the chat. I mean, that's kind of the nature of this I guess programming show. I don't know what it's called, but you know, live stream. There we go. We'll call it a live stream. Before continuing though, I figure I guess. Wait, what do you mean I guess? I forgot what I said. Oh no. I guess what? Hey, how are you, that your fan? I'm surprised to see you so early in the morning, actually. Usually you're here at like 6 a.m. or something like that, so usually in about an hour. So I'm glad to see you here. Okay, so what I was gonna say was, the other day, I think yesterday it was, maybe 2 days ago, I want to say it was yesterday, I don't remember. Anyway, sometime in the past, that was before 3 days ago, but maybe not earlier this morning, somewhere in between this time range. I was looking at the algorithm archive statistics, you know, the analytics for the algorithm archive, seeing who looks at it, what people look at, all this kind of stuff. A few things I noticed. One, it was kind of like, hey, I need to update the FFT chapter because that chapter is the one that is probably the most looked at, but also the, how do I put this? The least revised, like it needs a lot of revision. Now, the other thing I noticed is that we actually get a fair number of views on the algorithm archive content. Now, I know that maybe is not super surprising for a lot of people, but it was kind of for me. I actually get, if you discount my most popular video on YouTube, which is the Understanding 4D, the Tesseract video or whatever, if you discount that video, which is just an anomaly that is for some reason viewed a lot more than all my other videos, then we get the same number of views on the algorithm archive as we do on YouTube, and for better or worse, it's way more than the number of views that we get on Twitch. So it was one of those things that I kind of realized. I think that we are somehow very balanced between the three forms of content, you know, between Twitch, YouTube, and the algorithm archive. We've got a pretty good, I don't know how to put it, it's not like a trinity or anything, but we've got a pretty good group of, I don't know, content. Like, we have a pretty good thing going on here. And so I think I was pretty happy when I realized that, and I think it's kind of motivation for me to keep working on this project a bit longer, because I figure if we can get about the same number of views as we're getting on YouTube, as we're getting on the algorithm archive, then that's a pretty good sign that we're doing something right with the algorithm archive. And I want to keep working on it, obviously, in the future. I've mentioned that many times before, but I'm kind of more and more realizing that, like, ideally, if I could have a job in the future, it would be writing the algorithm archive full time. I don't know if this is a possible job, if it's something I can actually do, but it is something I want to see if I can pursue in the next year while I'm also finishing up my PhD. So it's just something I wanted to mention before getting started here. That your fan says it's 3 p.m. here, which means you must be in the Eastern time zone, I want to say. So probably somewhere in, I would say Boston, but I'm not actually sure. I'm just guessing Boston, because that's where all my friends are who are in the US and also in that time zone. Let me go ahead and get a quick sip of water, and then we'll go ahead and get started by checking. Let's go with that. maybe I'm wrong. Maybe I'm completely wrong then. But I swear 3 p.m. is the time it is in. We can Google this real quick. Let me Google it real quick, because maybe I'm wrong. I just know that if it were 2 p.m., it'd be the time it is in Alabama. Time in Boston. Has to be 2 p.m. Current local. 3 p.m. Yep. Okay, that's correct then. So it is 3 p.m. in Boston, Massachusetts. And again, I don't know where you are. I'm just saying maybe that's where it is. But it might not also be, because I actually know, now that I think about it, some other people who live in Washington, D.C., and some other people who live in, you know, like, I guess Virginia, in that area. So, you know. Oh, I guess South Carolina? Oh. Sorry for the yawn. I guess South Carolina is also in that same time zone. So maybe I do know a lot of people in that time zone. I don't know. It's a pretty big time zone. Lots of people in there. Okay, so let's go ahead and go to GitHub.com. So we were just looking at the PID chapter yesterday. I added a bunch of revisions, I suppose you could say. It happens. Every time we're going to have to be updating text, there's just going to be a lot of revisions that need to be done, which is unfortunately how it's going to have to go. Let's go ahead and go to issues here, and then also open up another tab for pull requests. And we're just going to take a look at these, make sure that there wasn't anything that popped up. I don't think there was much that popped up besides this guy here, which I think is a pretty easy merge. Let's see. Let's see, load diff. Def CCW. Did we update? No, it doesn't look like we did. But let me go ahead and take the algorithm archive.org real quick. So on the, to be totally completely honest, the Jarvis March is one that needs to be, updated. Definitely needs to be updated. Let's go to Python over here. Yeah, and let's see. He says he's updating it for PEP 8. And it does look like... Actually, I'm not sure how this is updated for PEP 8, honestly. But honestly, it should be okay. PEP 8? Wait, what's wrong with PEP 8? I mean, as far as guidelines are concerned for languages, PEP 8 is pretty nice. Being that, you know, unlike other, I guess you could say, language rules or whatever, like, this one's pretty well defined and pretty accepted in the community. So I think this one's good. Sorry for the yawn. I'm going to go ahead and review the changes here. I can't think of anything actually to update here. I'm pretty happy with that. It was just it looks like it's just a small scale change. JarvisMarch.py, JarvisMarch.py. Oh, wait. The file name has been changed. But it doesn't look... I doubt that this was reflected in the chapter itself. So let's go here and let's say, let's see. Command line instructions. Let's go ahead and grab this guy and let's build it real quick. Man, I'm sorry I have the hiccups. I have nothing against it. I'm just being stupid. It's fair enough. All right, so we're going to do git book serve. And I've got a feeling there's going to be an error with this. And I'm just going to check it just to make sure. And if there is an error, then we'll just go ahead and mention that error and say we can merge after that. Let's see, keep going. Let's go and do localhost, open link, and we should go down to Jarvis March here, and we're going to take a look at the Python. Yep, file not found. That's exactly what I expected. Although, interestingly... Oh, this must be from the old version. Okay, yeah, this is fine. So we will go ahead and mention that. The file name was changed. Could you also update the markdown file to reflect this? All right, let's go ahead and comment there. And then it's done. I think that's fine. I guess I should go ahead and edit this and say, I set that. I see no reason. It's fine. Okay, great. So let's go ahead and pop over here and let's do a quick Control C, git branch. And let's go ahead and remove this branch that we have here. So git checkout master, master. There we go. And git branch -d. And we'll go ahead and delete this branch that we have because it's kind of unnecessary to have on our local machine. Okay, good. So that's one pull request done, which means we only have like, I don't know, 32 pull requests left. After we do the chapter pull requests, we have like 27 pull requests left. Actually, let me go ahead and double check how many chapter pull requests there are, because there sure are a lot of them. So we have 1, 2, let's see, 3, 4, 5 at least chapter pull requests. It doesn't look like this one's going anywhere. So we might go ahead and do the C++ Gaussian elimination chapter elsewhere. You know what I'm saying? Like we might just go ahead and basically there are 2 C++ Gaussian elimination chapters that have been submitted, right? This one was submitted a super long time ago, but it's stale. No one's actually doing anything with it. And the updates that we asked for weren't actually done. So, yeah. We probably just need to get rid of it and start working on a new one. Hey Trash Talk, how are you? I hope you're having a wonderful day. Okay. So now the question is, what do we do today? And we've got a couple of things that we could do. We could start working on the animations for the PID chapter. This would be a nice thing to do, but on the other hand, we could also start working on revisions for the Fast4A transform chapter. Or we can keep working on animations for our spherical cow logo. There's actually a lot of different things that we could do. And in fact, we don't have to work on animations at all. We could just, work on the revisions instead of just the FFT animations, you know what I mean? So what I want to do is actually, I think right now, I want to take a look at what the Algorithm Archive FFT chapter currently looks like. And I just want to make a note of all the things that need to be updated with it. Then after that point, I want to just kind of figure out where we want to go with that chapter. And I think what's going to happen is this Saturday, let's do it. Oh, that's not what I wanted. Cute. This Saturday, let's go ahead and do Cal over here, which will be on Friday the 28th your time. And again, it's going to be Saturday the 29th my time. I think I'll do a longer stream where we're just kind of going through the FFT chapter and trying to figure out what it is that needs to be done. You said a Christmas dinner. Wait, what? It's the 27th my time. Were you celebrating Christmas a day late, or what happened? I thought for a second I was like way off in terms of times, but it is the 27th my time. I have the calendar up right there. Is that Mead 2018? Hey, thanks for coming in. Or is it my day? I'm not sure which one it is. Let me go ahead and get a quick sip of water. Okay, so I'm going to... I'm going to take a look at the FFT chapter, see what we need to do, and then probably spend the rest of the day working on animations, unless someone in chat really, really wants me to work on something in particular. Otherwise, yeah, I think we'll kind of work on some animations today. We have a lot of animations to work on. The Gatsby library has some updates that need to be made. It's good. We have some stuff that we can definitely work on. Nice. Now today, Tim, at the end of our stream, will be basically doing a long play test of his new game or whatever. I'm hoping that it finishes, or that he starts, how do I put this? That he starts his playtest at around the same time that I'm finishing my stream. Otherwise, I don't know how we're going to manage, because I did specifically mention that I was going to be rating him at the end of stream, and if I can't rate him at the end of stream, I'm not really sure what to do. Lungu97, thank you so much for following, really appreciate it. Okay, so now what we're going to do is we're just going to take a look at the FFT chapter, see what needs to be done. So I'm going to move over here, yep, over there, and also let me move that to that desktop, and I'm just going to do git book. Actually, how about we do git branch, git checkout, dash, git pull, org master. So we're going to go ahead and pull the latest changes. We're going to push those to my own origin. Yep. And then after that, we're just going to do a quick git checkout -b, and we're just going to say FFT updates. Okay, cool. So we have the branch ready. So now we're just going to take a look at what we need to do. Now, again, I have a list of things that I think need to be done, but I want to kind of look at it and see what else needs to be done. Yeah, you're fine. We get 2 free days on Christmas, and we had a big meal today. Oh, that's fair enough. Hey, I'm not Swak. What is up? And again, I'm not sure if I'm mispronouncing the name. I'm always mispronouncing it, I feel like. Good evening. Okay, so I'm going to do a quick git book serve, and we're going to see what happens. All right, so a few changes that have been made as of yesterday to the Algorithm Archive. We've made it so that all code now is actually black background, white text. I don't know if this is necessarily good. I kind of don't like the big change in style between the white background and black text, and I'll show you exactly what I mean here. Let's go ahead and take a look here, open link. And if we go to Euclidean algorithm, for example, now all code is with the same kind of black background, white text type of thing, which is ultimately fine. I don't mind it so much. It looks way better when we do dark mode. I don't know how many people actually use night mode, but yeah, that is something, it does look a bit better. Honestly, the sepia one, I like this one best. I kind of wish all of them looked like that, but that's okay. The night mode one does look a lot better in this way. And I think the night mode and the white mode actually use the same code block now. I don't know if I'm necessarily the biggest fan of this, but hey, it is what it is. So let's pop down to the FFT chapter. Okay, of all the changes that need to be made, one thing that certainly needs to be made is we need to split up the Fourier transform with the fast Fourier transform. We need to basically put the Fourier transform here into mathematical background, so we have it here. Because quite frankly, the Fourier transform is used in a bunch of different algorithms and methods, you know. It's not necessarily just used, you know, for the fast Fourier transform, right? Like the idea of the Fourier transform is used For example, in the split operator method and in a bunch of other places. In fact, if we go down to the split operator method, here we're going to do FFT. Yeah, so I've written FFTs. Let's see, I probably wrote Fourier a few times. Yeah, Fourier transforms. And again, this probably just links to the FFT chapter, and it should link to two separate groups. Is that Algorithm Archive a website project? I mean, the Algorithm Archive is it's a book, right? So here, let's go here. It's on algorithmarchive.org. It is an open source, open access book. It's part of the big OER, Open Educational Resources group, I guess you could say. But yeah, the idea here is that it is a, how do I put this? It is a collaborative effort to document as many algorithms as we can in as many languages as we can. So for example, you go to Euclidean algorithm here, you can check between all the different languages, lol code, wait, what was that? Oh, Piet. And it has basically all of the different language implementations for each different algorithm, including the text chapter for that algorithm too. So it's kind of the idea is that we are providing essentially, if you've ever heard of numerical recipes, we're kind of competing in that space. So it's kind of a mixture, you could say, between numerical recipes and, for example, Rosetta code. However, I would argue it's quite different than both of these things, because it also is in some scale or in some sense a very large community project that we're working on together. Basically, I'll be writing most of the chapters and then everyone else writes the code. However, that is changing recently. Once we get the a particular pull request merged into the Algorithm Archive, which is going to be this guy over here, one second, should be, yeah, once we've changed all the licensing to BCC by SA, at that point, we will then basically be allowing for other chapters to be added in by other people. So at this point, it's basically, I write chapters, everyone else writes code, but soon it's going to be pretty much anyone can write chapters. But again, everything has to be revised and edited by the community before it's put in. So it's not, it might sound kind of chaotic, but it's not as chaotic as it sounds. I think for the most part, we've got a pretty good handle on how this is going to go. I would like to be basically hand editing all of the chapters, and then we'll let other people kind of still review and do everything with all the code. So far, it's been majorly successful, although admittedly, I've done my first internship project. Oh, cool. How'd it go? Admittedly, with the Algorithm Archive, we got a lot of work to do, but that's okay. It's one of those projects that will always have a lot of work to do. So sorry for the ramble session there. I'm just hoping that it is like one of my favorite projects I think I've ever worked on, and I'm really hoping it goes pretty far. Again, as I said earlier, I'm not sure how many people were here when I said that. The Algorithm Archive is currently getting about as many views as my YouTube channel, which again has a super large number of views compared to Twitch and stuff like that. And got my second task. Deadline is Monday, and this week is very, very busy for me. Dude, good luck. I know how it goes. I am hoping you have you get everything done and it works very well. If not, again, it is your first internship, so you have a lot of time to figure out how to do basically what you need to do. Man, I'm so tired today. I cannot form coherent sentences, but yeah, good luck. Alkalamin, thank you so much for following. I apologize for missing that about a minute ago. Okay, so let's keep going. As far as this chapter is concerned, there's a lot of stuff that need to be updated. Like, first of all, we need to update what the Fourier transform is. My question is, should we put the discrete Fourier transform in with the regular Fourier transform? And the answer to that is, I think yes. I think we should have a separate section for the Fourier transform, and in this section we mention the discrete Fourier transform, because the discrete Fourier transform, actually, you know what? Maybe what we should do, yeah, and these images have to be updated too. There's a lot of stuff that need to be updated. The example code, yeah, it all just has to be updated. Okay, so what we need to do then is we need to split it up so we have the Fourier transform chapter, then we have the fast Fourier transform chapter, and then within the fast Fourier transform chapter, we have the Cooley-Tukey method, which is what this method is particularly, right? So the idea then is that we have, Fourier transform, fast Fourier transform, and the Cooley-Tukey method. The Cooley-Tukey method is, of course, only one of many methods that can do the Fourier transform. What are these algorithms for? It's for learning the algorithm. You know what I mean? You've been here before, man. I know you've seen the Algorithm Archive before. I've just discovered GitHub, TrekHub, JavaScript algorithms last week. That's a funny coincidence. Yeah, the Algorithm Archive, again, is primarily meant to read as a book. It's primarily meant to be a book. It's again like numerical recipes or something like that. There are a lot of people who, I guess, need or require better resources for teaching and understanding algorithms, and this is meant to be your kind of one-stop shop to understanding as many algorithms as you can. And so that's kind of what we're shooting for. We want to cover as many methods and algorithms as we can. And also, of course, this is very closely related to my YouTube channel and obviously Twitch stream and stuff like that. Oh, today's algorithm, yeah. So right now we're looking at the Cooley-Tukey method. It's for fast Fourier transforms. If you don't know, I'm sorry, I misunderstood. Oh, okay, never mind. Yeah, I misunderstood. I thought this was a general question on the algorithm archive. But today, in particular, I'm looking at the Cooley-Tukey method, which is a method to do the fast Fourier transform. So the fast Fourier transform is, well, like it says, it's a fast Fourier transform. The Fourier transform is basically a way in which we can transform between one coordinate system into another coordinate system. Now, one thing that we've changed since I wrote this chapter one big thing that we've changed is how we do the images and stuff like that. So before, I kind of showed this weird image where we show some sort of weird mess, complicated mess of signals in real space, and then some sort of, defined peak in frequency space. And I think this is fair, but it's not really obvious exactly what it is that this image is depicting, right? Because, I mean, I know what it is. I know that each of these three peaks represent the corresponding frequencies over here, so these are three sine waves kind of put together, and we see three defined peaks in frequency space, and that's fine. That's what you would expect. But I think we could better visualize this again with some sort of quick animation here, similar to what I did on the fast Fourier transform video, right? So if we have, some of these waves moving around, right, then you can clearly see, as this frequency changes, one of these peaks changes. You know what I mean? And so this is something that we need to add in there. Also, as far as the images are concerned, I really need to find a better way to visually depict these butterfly diagrams. I don't think the way that they look is bad. I think their image is fine. But I think it's not clear, at least to me, it's not clear what these butterfly diagrams represent kind of geometrically, And so I kind of want to more accurately show what these butterfly diagrams are doing. You can link a video, but I can't watch it on stream, so it's not going to help. Hey JSPP, thanks for coming in. So again, those are the big things that we need to do. We need to split up the chapter, we need to create better images, and we need to figure out a good geometrical representation for what the butterfly diagrams are doing at a at kind of a fundamental level, if that makes sense. So I'd like to have some sort of description of the Fourier transform in geometric space, which a friend of mine has. I think maybe I should do a better representation of that, if that makes sense. Like I should ask him how or what he what he thinks for the visualization, and then kind of do that visualization on our own. So I think maybe this is where we're heading with this visualization. And again, like I said, I would like to kind of start working on this visualization soon because there's a lot to do there. But there's also the visualization for the PID chapter that we need to get done. So there's a lot of different things that need to be done. But right now the PID chapter isn't really my business, that's more Gathros' business. So I'm kind of more keen to do the Fourier transform animations now. We got to figure out how to get an Xbox controller working in Wine. Why? I'll be honest, like that is not a problem I've ever run into before. Let's see, open link. Oh yeah, this guy. Yeah, I know Coding Train. Obviously, Coding Train. He's a good friend of mine. I did not see this video yet. Now the Fourier series is another thing we need to cover. I don't know how to really point it out, but I guess what I want to say is that how do I put this? What I want to say is that this guy's a really good guy. We need to talk about Fourier series also on the Fourier transform video. Oh, Antihei, thank you so much for gifting the Yuhei. I'm sorry, I'm mispronouncing everyone's names, but thank you so much for gifting them a sub. I really appreciate that. Let me go ahead and say Simule Cow in the chat. I'm hoping, thanks a lot, really appreciate it. The Christmas spirit, yeah, I really appreciate it. That was really nice of you. I really appreciate all the support you guys give the channel. It's one of those things that, again, like this is a community effort, and I really appreciate this community because they are amazing, and everyone in this community is great. There is one thing that I did change about my YouTube, I guess you could say, overlook. I don't know. I changed YouTube a bit. So now I have a new a new extension on Firefox, which basically removes all suggested videos from my YouTube viewer, I guess you could say. So like I have no suggested videos here, and I have no suggested videos here on my homepage. And the reason I did that is because I realized last week I spent 4 hours just sitting and watching YouTube videos. And I was like, that is 4 hours I could have spent doing other things. You know, like even playing Super Smash Brothers is more productive than watching these YouTube videos, because at least I like playing Super Smash Brothers, you know? Watching the YouTube videos, like I don't know what I was doing. I was just watching the YouTube video. I was like, yeah, okay, this is something. I just didn't even like any of the videos I was watching. This wasn't 4 hours of me watching like 3 Blue and Brown or Coding Train or channels that I appreciate and I know, and like, you know, I actually care for the content creators as friends. But this was just me watching videos that I didn't care for, like off of Alpha Rad and like, you know, Psycho Plays and all these games. That's just kind of like, why? So anyway, doesn't really matter. Point is, I've now removed all those videos. Yep, seeing you cow in the chat. Thank you so much for the gifted sub again. I really do appreciate that. But yeah, so I just want to say, if you're interested, there's like this kind of remove all suggested videos from YouTube, and I've started doing that, or I'm going to keep doing that in the new year, because it's just, I don't know, man. I kind of realized I've been wasting a little bit too much time doing that. I don't watch gaming on my main account. Makes all the suggestions bad. Yeah, I probably should have kept up with that. Mouse6, thank you so much for following. Really appreciate it. But yeah, so that's the thing. If you guys are interested, I think it's a good solution to a bit of an annoying problem, which is that, you know, sometimes when you're watching a YouTube video, you're just not satisfied with one YouTube video, so you just click on more and more YouTube videos until you've eventually wasted like hours of your day just watching YouTube videos when you know you could have spent that more effectively doing something else. And that's kind of the case with me in particular. I've just got so much work to do. Wasting any time on YouTube is just not worth doing. But yeah, the 4A series is another thing that we could probably do a better visualization of. Let's see, it's open source, right? Yeah, it is. It's oh, I put it on Discord, so let me go ahead and give you guys that link. It should be over here, and it should be on off topic, I want to say. No, maybe I accidentally put it in general, but yeah, here it is right here. So this is a link to remove YouTube suggestions. Again, if you guys really like watching YouTube, there's nothing wrong with that. Watch as much YouTube as you want. There's no problem. It's just if you're wasting time watching YouTube, this is actually pretty useful, I would say. And again, you don't have to do it. It's just something I'm trying to do in the 2019, and we'll see how it goes. It could actually be like horrible. I don't know how it could go bad, but it could be pretty bad for me. I mean, you still have your subscription box, so like this box still works. Who am I actually subscribed to? Ooh, this could be quite bad. Oh no, these are all pretty tame. I'm not subscribed to anyone crazy. Biscuit! Oh yeah, Biscuit! Okay, anyway. PewDiePie. Oh, I'm subscribed to PewDiePie. It was for the meme too. Some guy was just like, you should subscribe to PewDiePie. I was like, yeah, okay, I'll subscribe to PewDiePie for this guy. Anyway, what's up? How are you coding with ethanol? Okay. So we've got a good idea of all the visualizations we need to do for the Fourier transform chapter and all this kind of stuff. So we have a choice. Should we work on the Fourier transform revisions, or should we work on the new images that we need for the Fourier transform? And I think at this point, I want to work on the images. Now, granted, we could also work on the animation of the spherical cow logo. This is kind of up to you guys. I don't mind doing either one, but I do know that we need to work on both the Fourier transforms and the spherical cow logo, kind of in tandem. In tandem, is that the word? We need to work on them both in parallel. So I'm up for working on either of those guys. If you guys have a preference, feel free to let me know. I guess I can do a quick, I linked the YouTube video and effed everything up. No, you're fine. You didn't F anything up. I was just letting you know. It's kind of a nice, wait, what did you F up? I just want to let everyone know about this cool new application that I'm using in Firefox. I apologize if I started rambling for no apparent reason, but hey, it's not your fault. I just thought it was kind of cool. The Coding Challenge guy, yeah, so Coding Train is honestly an incredibly inspirational channel for me. I really like that guy. Dan is one of the nicest guys I've met, or I met at ThinkerCon. He's just such a cool guy. I mean, we did a live coding challenge together. In my next video about fractals, I'm definitely going to be mentioning that. Speaking of which, I want to get the Fourier transform chapter stuff done before moving on to the next, I don't know, the next video, which is going to be on fractals, particularly iterated function systems. That way we can kind of split the fractals up into iterated function systems, you know, maybe the fractal flame method after that. In fact, that's probably a good way to do it. We'll talk about the fractal flame method after talking about iterated function systems. So we can do 2 videos on fractals in case I'm kind of behind in a later month or something like that. Yeah, that's probably a good way to do it. Yeah, that's actually probably the best way to do it. And then we can, obviously I'm going to, I don't know, I want to highlight a lot of Foldster stuff in the Fractal video that we're going to make. I don't know, there's a lot of stuff to do. Okay, so let me just go ahead and create a quick straw poll. I know this is kind of dumb. I shouldn't put a straw poll on all of my, on all my streams, but I just don't care. I can do whatever. Like, there's so many things I could do right now. So let me just go ahead and do straw poll over here. I'm going to say, what are we doing today? What are we going to do today? And so we can do FFT animations. And then we'll say FFT revisions. Oh, that's 2 S's. That's way too many S's. Then we'll say, I don't know, spherical cow logo. PID animations. Other. Your mom. Oh, that's probably. I'm not gonna make that joke. Okay, let's go and create the poll. I just realized. Yeah, okay. As far as capitalization, I apologize for that one. Yeah, so I don't care. We'll do whatever. I'm up for whatever. FFT animations, FFT revisions, spherical cow logo, PID animations, other, whatever. You know, I'm cool. That's definitely not true. Let me get a quick sip of water. Okay. But yeah, I guess maybe I'm more keen to do the animations of the cow logo and FFT. But again, if you guys want to start working on the revisions, I'm up for that too. I was thinking about doing a long stream on Saturday where we just go through the FFT current chapter, we work on all the revisions, I get some more citations in there, you know, do everything that we need to get done. Trash Hop rolled a 1. Nice. Okay, let's take a look at the results. We have... everyone wants to do FFT animations. Yeah! Alright, let's go. Yeah, it looks like more and more people are just voting for FFT animations. And we have one comment which says, Simul Cow, nice! Oh, I'd give that a +1, but I don't think I can. No, I can't. Let me check something real quick on my side chat. I just got a notification. I know I ever since I started putting on this this second screen that is essentially just a laptop on the side, I've been using it a lot and maybe a little bit too much. Like I keep looking over here, and I'm hoping that everyone knows that I'm looking at like a side screen with just stuff on it. I don't know what kind of stuff. It's stuff. Okay. Also, I got a whole bunch of other messages. Oh my gosh, why do I get so many messages? Okay, good. All the messages are now looked at. We're good to go. We get this OIST Research Events Digest of all the stuff that's going on every day. And it's just so much information. But today, it says there are no events today. But then it has all these ongoing events, so the email is still ridiculously long. It's okay. It is what it is. Let's pop back over here. And let's go. Okay, so it looks like most people are going for FFT animations, and I think that's probably a good idea. So let's go ahead and do that. So I linked a YouTube video, effed everything up. Hey Simuleos, what's up Neuropilot? Delurking, what does that command do? I actually don't know either. Does that just mean that you're going to be lurking? I'm not sure. Okay, so let's go. For the FFT animations, there's a few animations we want to start with, right? So I guess what I'm gonna do is I'm gonna just quickly create some sort of animation for the Fourier transform, which is going to be basically representing this animation right here. Because there's so many easy ways to do this, I don't see a reason not to just use a standard plotting language. Like for example, when we did the split operator method down here, we basically just used Julia to do these animations down here. And so why not do a very similar thing for our Fourier transform video? We just have some sort of quick GIF animation working there. I think it should be fine. Yeah, not sure, trying to be funny. Oh, it's okay. I don't think people just didn't understand where you were going with that. Cool. Okay, so let's go ahead and get going with this. Also, if you guys notice, I have dropped the stream latency down, so I'm using the, I guess you could say lower latency setting today, so that you should only have like a second in between what I say and what you guys say and all this kind of stuff. So let me know if you guys are running into any troubles watching today's stream, because I know that this has led to trouble in the past with certain people. But if there are problems with you watching stream, just let me know. If there are no problems, then maybe we'll just kind of keep the delay small. Again, maybe, at least I think that, let me double check, but I'm pretty sure I did enable that setting. So let me double check over here on the side. 10 seconds seems way too long. Let me go to the dashboard over here and let me double check, because I was like 90% sure I totally have the low latency enabled Let me go down here to settings. Wait, what? Oh, actually, I don't know how to do this. Extensions, channel, stream summary, settings, channel settings. Yeah, it says low latency. So I do have low latency enabled. It could just be the case that, oh, I don't know how to put this, but it could just be because I'm still so far away with being in Tokyo and everything. Well, being in Okinawa and this moving to Tokyo. And then everyone kind of streaming from the Tokyo server. Maybe it's still quite far away. I'm not really sure. But that's okay. It is what it is. Let's see. Yeah, it is what it is. Okay, cool. So we'll keep going. What I'm going to do is I'm going to go ahead and move on to a new directory over here. So we're going to cd into projects, Simulaos. And I guess I'm just going to put all the visualizations here. So let me do a quick ls here. And I think we have one for split up too, ls. Yeah, so I think these are all the density images. So let me just do a quick mirage. Density 000, I guess it's going to be 0.png. And yeah, so these are all the visualizations I think I used for my split operator video. Actually, maybe this is just for the thumbnail. I'm not really sure. Regardless, it's just a bunch of images of the split operator method working. Okay, so let's go ahead and cd back a directory, and I'm gonna go ahead and cd into FFT, which I believe I have. I do not. FFT. Oh, I do have it. ls. And I'm just gonna go ahead and create a quick Fourier transform. I guess you could say animation. I don't really know how else to put it. I'm going to basically take something in Julia, like some sort of complicated mess of waves, plot it with the Fourier transform, go from one to the other, and then I'm going to do an animation of this. Is this Linux? It is indeed Linux. So we're going to cd into projects, Simulaos, and FFT over here. Now I've got this thing called fft-slow.jl. Let me take a look. VIFFT-slow.jl. I'm not sure what this is exactly. Oh, this was probably my first implementation of the Cooley-Tukey method a long time ago. Why do I have Monte Carlo in here? Wow, this was done forever ago. Oh man, I'm totally remembering this now. We did... What were we doing here? I was trying to describe L1 minimization via the Fourier transform, trying to go into compressive sensing, which I still want to do. Man, I want to go into compressive sensing. It's so cool. Testing again. Guess I was lagging. Oh yeah, I don't know. I don't know how Twitch works, if I'm being honest. The actual distribution I'm using is Arch Linux, and the desktop manager or desktop environment, Windows Manager, is OpenBox. So if you're interested, I mean, just, you know, that's kind of what I'm working on. Hey Gathros, what is up? So I'm over here on the FFT, in the FFT directory, so I'm just going to run Julia over here. And I guess I'm just going to run using plots. Just to make sure I have plots installed. I do not, so package using package. So if you guys remember, the reason I don't have plots installed is because for the recent GPU computing stream, I basically had to update Julia to Julia 1.2.dev or whatever it was. And this basically made it so a lot of my previous libraries that I had installed in Julia were no longer installed. So I'm gonna have to reinstall some things. That's how it was. I know syntax highlighting these days? No, I don't use syntax highlighting. I mean, I know a lot of people, they really like syntax highlighting, but it's not for me. I just don't like it. So we're gonna use using plots. And I'm just gonna very quickly plot something just to make sure it works. Now, admittedly, the plots package is a bit funny, or at least it has been a bit funny for me since Julia 1. So I'm hoping that the plots package has now been fixed in Julia 1.2 dev, but we'll see how it goes. So right now it's pre-compiling the terminal, or pre-compiling the plots package, and we'll see how that goes. Again, I hope everyone's having a wonderful day today. Feel free just to talk about whatever it is you're doing. I know it's the holiday season for a lot of people still. I know for me, I'm going to be having January 1st, 2nd, and 3rd off. Today I don't have off. Yesterday I didn't have off. I don't have off tomorrow, and I don't have off on Monday. But that's okay, because I get January 1st, 2nd, and 3rd off. Oh, one thing I do want to talk to you guys about. What I was thinking about doing, and I realize this is a bit of a stretch, but what I was thinking about doing was doing a very quick Contributors Corner video this weekend. Now, I haven't done one of these videos in a while, but I hadn't been doing videos in a while. So what I was thinking about doing is doing a Contributors Corner video on this Sunday, just describing basically all of the recent updates, all the changes, everything that's cool that's been happening with the Algorithm Archive recently, including Hacktoberfest, because I'm missing that, and a bunch of other really cool things. Such that we basically have a year wrap-up video. And I don't know if that's interesting to you guys or not. We don't really have to have it. I think maybe it would make more sense to happen after the fractal video. I don't know, lots of things to do there. C252, hi, hopping in for a minute. Hi, what's up? How are you, man? I hope you're having a wonderful day. So yeah, what do you guys think? Should we do a Contributors Corner year wrap-up review? Let me rephrase that. Should we do a Contributors Corner year wrap-up? I guess review is the correct word there. Huh. Okay, never mind. That was fine. It just sounded weird. Regardless, we could do it. Or we could wait until next year to do it. Because if you currently look at my videos, it looks like my very last video before the Gaussian elimination chapter was actually a Contributors Corner video. So people are all more or less okay with doing a Contributors Corner video this weekend. Because I can do that. The main advantages of doing it here would be that, you know, it's like the end of 2018. We can talk about all the cool stuff that's been going on with the algorithm archive, all that kind of stuff. But I think that maybe it also makes more sense to do after my next video on fractals, because then that's when all of the chapter revisions will be completed. And so we'll kind of work on that. Does this animation look good to you? Open link. What do we have? Oh, whoa, what happened here? Oh, I see. So, wait, actually, no, I don't see. What's happening? The car is starting here, and it's trying to move towards the line. And so the instability causes it to spiral out of control here. Is that what we're looking at? If that's what we're looking at, yeah, it looks pretty good. Paint Artist, thank you so much for following. Really appreciate it. In that case, yeah, it makes sense. I mean, you might want to put an explanation explaining that this line is the car's motion. So this is the car's trajectory. And in that case, yeah, I'm a fan. I think it looks pretty good. The only other visualization I think that might look cool is if like we had an actual car. Like that was just spiraling out of control over here. But honestly, I like the fact that we're tracking the trajectory. So like the only thing I could say that you could add to this to make it look better is if like we had like a little box that represented the car that was moving around and showing that this is like, you know, it's going, but that's the only thing I would say. I mean, maybe change the line color, but I don't know, maybe describe that this is the line and this is the car or something. I don't know. But ultimately, yeah, I think it looks pretty good. I'm actually a big fan of that. And so if we had these for each of the instabilities that the car was undergoing, like, you know, you said that there's a couple different things that could happen. It could kind of like oscillate back and forth on the line, and it could do things like that. Those would be very good instabilities to show. And I think if we could show that, that's perfect. I'm a fan. I think this is a pretty good step forward. For the algorithm archive, usually we do a white background with black lines, and that's basically what we have. Here's a good video. Open link. What do we have here? Yeah, something like this. Yeah, okay, and here's the oscillations that we were talking about before with the proportional control. Yeah, so this is kind of what we want. I think that they're a little bit too messy. Just slightly too messy. Because I think there's just too much background information going on. And I think this is because, I mean, they're not doing a simulation. I think this is an actual video of their RC car moving, right? And that's cool. There's advantages to that. But it just, for the purposes of the algorithm archive, it's nice just to have like the blue line and then the red line. That's all we need. We don't need additional lines on top of that. Again, maybe a box to represent the car, but we don't need anything else. And again, stylistically for the algorithm archive, we usually go with white background with black lines instead of black background, white lines. But then for my videos, I do black background, white lines. So I will be making a video on this, I'm sure. So, you know, it's something that will come up. That's another nice thing about having, I guess you could say, multiple people creating chapters for the algorithm archive. It does kind of help in video production a bit. So like, we could get to the point where I'm using the algorithm archive as like the fundamentals behind the videos that I create, if that makes sense. So that would also be kind of interesting. Although I'm not sure what to do with the ad revenue in that case. Like maybe I should provide the ad revenue to the people who created the video content. I'm not really sure. We'd have to kind of discuss that on a case-by-case basis, I guess. So anyway, that's something to discuss in the future. Okay, so let's keep going with our FFT animation. So I'm going to go ahead and create a very quick, just A equals 1, 2, 3, 4. Okay, 1, 2, 3, 4. All right, and we're just going to plot A, just to make sure the plotting works. Plot A. No, it's fine. Well, for this case, but we do need to talk about it on a case-by-case basis, you know. Plot A is working, I guess. It's doing something underneath. I guess it's still pre-compiling things. I'm not sure what it's doing. Come on, dog. Do something. Plotting shouldn't take this long. What are you doing? Right now we're working on updates to the FFT chapter. So we're going to be doing animations and basically... Oh, I see what happened. Okay. Anyway, we're going to be working on animations and stuff for the FFT chapter. And that's what we're going to be working on right now. Now, I think I realized what happened here. So let's go ahead and do, I think A. Yeah, A is a two-dimensional array. What I wanted it to be was A equals 1, 2, 3, 4. Here. So now it's a 1D array. And let's go ahead and plot A now. And this should do, yep, that's our straight line that we expected. I think the ad revenue would be too small, that it wouldn't be worth it. Yeah, it could be true. I mean, I don't know. As far as the ad revenue is concerned, I mean, we also get, I mean, potentially we get sponsorships and stuff like that. The ad revenue is not so bad. Like in the last video, it got 11,000 views, right? Or 15,000 views or something like that. Which basically was, you know, $30. I mean, that's not really not worth it. You know, it's kind of somewhere in between. Give me that one penny. No, I mean, the ad revenue is okay. Like, it's not awful. I don't get nothing. I get stuff for the algorithm archive. But honestly, I don't get paid that much. Like, for all of my YouTube channel, for all of my videos put together, I make like $5 a day, basically like that, off the algorithm archive, which admittedly is not bad. What is the algorithm archive? Sorry about that. Let me get a quick sip of water. I'm just, my throat is just not dealing with it today. Yeah, Gathos has it. The algorithm archive is a collaborative effort to document as many algorithms as we can in as many languages as possible. So if you go to the algorithm archive, let's just go there real quick just to show you what it is. If you go to the algorithm archive, like let's say the Euclidean algorithm, or let's just split operator method because that's closer to what we're doing today, you can just go ahead and switch between all the languages that we have for that particular algorithm. So it works better with like, we'll say, let's just do the stable marriage problem. Why not? So you pop down here and you can just change between all these different languages that we have for the stable marriage problem. And they're all just quick examples of, I guess, how to perform this particular method in these languages, right? So this is meant to be kind of like numerical recipes, read like numerical recipes. I mean, it is supposed to be a book, but in the end, we have every language available. So it's kind of like all algorithms, all languages, some sort of crazy, you know, pipe dream that's completely impossible. But, you know, we're getting there one step at a time. It's a really cool project, and I'm hoping that, you know, people here really enjoy, I guess, just messing around with it, you know? We'll see how it goes. Okay, so we have the plotting working. Again, I apologize, it took a second to install the plotting library and everything like that, but it's working now. So I'm going to go ahead and create a very quick sine wave, and we're just going to do the FFT of the sine wave, and we're going to plot that. But remember, C is the best, not only because it's great language, but it's always there for new algorithms. That's true, but also so is Julia. So like, and also usually so is C#. But you're correct in that I think C is, I think C has just as much coverage as Julia does. And it's relatively straightforward to read for people who are trying to write C++ code, whereas the C++ is honestly a pain in the butt because no one knows how to write C++ code. Okay, so let's go. We're going to do, A is going to be equal to, how about, sine of 2 pi. We'll say sine of 2 pi. So we're going to go from 0 to 2 pi. So 2 pi. And I guess we're going to go from 0 to 2 pi. So this is going to be times some resolution, right? So it should be 2 pi divided by 100, we'll say. So we have 100 elements here. Sine 2 pi, and I guess it's going to have to be 2 pi I times I divided by 100. And then we're going to say for I equals 1 to 100. Okay, so let's go ahead and plot A one more time. Okay, so there's a sine wave. It does look a little bit jagged. I don't know if you can see that or not, but it does look a little bit maybe low resolution. So let's do this 1 to 1,000. So we're going to say for I0 to 1,000, just so that we have a slightly high resolution sine wave that we're adding on here. Okay, so now we're going to do plot A. Nice. It's a small plot, but when we make it bigger, it looks okay. Okay, so now we're going to do FFT of A, and we're going to set this equal to B. FFT not defined. So we're going to do, what is it, use package FFT. It's going to be package.add. And I guess the package we want to add is FFTW, I'm going to assume. Because usually what it is. Julia is sometimes hard to understand what's going on, like in the FFT. I don't know. It kind of depends. Especially the speed aspect of C does fast algorithms justice. Yeah, that's true. So we're gonna say using FFTW. Is that true? It shouldn't be. Julia should be much easier to understand in most cases. Let's go to FFT here. Let's see here. I think it's fine. I mean, it's relatively easy to understand, I think, because like, I mean, maybe you don't know what VCAT is, but I mean, it's a vertical concatenation. It's not even functional. Julia is kind of like, yeah, maybe. Look at C. But I think the C code's actually harder to understand because then you have to do with, I mean, don't get me wrong, like we're arguing what's hard to understand, and ultimately it's fine. Like it just depends on what people are used to. Yeah, let's see. Iterative Cooley Tukey approximate. Wait, what? Oh, this code needs to be updated. Definitely needs to be updated. The heck? Yeah, what the heck is going on with the C code? What the heck? You're not even testing the C code. Julia was built for ninja coding. No, I mean, honestly, this depends on the person, right? For me, Julia is way easier to follow than C code, depending on what you're doing, right? But I also understand that C is easier in some cases. But yeah, so C definitely needs to be updated though. So that it's reading in the FFTW library and you're actually approximating the result. I don't know what happened. Like why what? Huh. Okay, so I'll go ahead and create an issue on that, or maybe I'll just go ahead and update it. It's not too hard to update. But basically the problem is here we're comparing the Cooley Tukey method with the FFT method, right? So we're actually comparing it to an inbuilt FFT method for Julia. With C, we're just comparing the two methods. We should have actually been reading in the FFTW library and just running a separate FFT such that we're comparing the results from our Cooley Tukey methods, iterative Cooley Tukey and just recursive Cooley Tukey with the, I don't think I changed that. I think it was always like that. Python should be doing the same thing. What the heck? Why are all of these guys wrong? The heck? No way. That cannot be the case. That absolutely cannot be the case. I know I would not have put that chapter up. Let me go ahead and CD into projects, algorithm archive, CD into, at least the code looks good now. No, I don't think, I don't know, because I know I put the FFT in there. I would not have done this any other way. So CD into, because I always add a test for the code that I put in the algorithm archive, and then somehow people ignore it when they're actually writing the code itself. And then when they ignore it, then they're like, why are there no tests in the algorithm archive? It's like, there are. Every time I put code, there's always a test to make sure it works. And then people are just like, but there's not any in this code. It's like, well, I don't understand why not, because like they weren't following the Julia code. So it's like, I don't know. It happens a lot. So CD into contents. I'd be super surprised if not. CD into FFT. Fast. Where is it? Cooley Tukey. Yeah, CD into code. LS here. CD into Julia. Git log. FFT.jl. Let's see. Implement flat hierarchy. Oh, I'm not gonna be able to see the. Shoot, I'm not going to be able to see the full history because we modified it. No, we can't do get blame here. Yeah, I don't think we're going to be able to check it. Dang. But I know for a fact when I wrote the FFT code, I had it tested against the FFT here. I think there might have been a discussion at some point where you mentioned that it's hard to do. I think I slightly remember this discussion. I think basically what ended up happening is we said, you were saying that it's hard to read in the FFTW library for some reason, or we weren't sure whether we wanted to read in the FFTW library or something. I was always sure. I was like, yes, we need to read it in, but I think we had a discussion against that. That was for convolutions? What? What do you mean? Why? How can you guys... That was for convolutions. No, look, I can guarantee you that, like, I had a test. I always have a test. Huh. Because no matter what code, I always make sure I have a test to make sure the code is working properly. Which is one reason why I use Julia as a primary language here. Because again, it's super easy to understand. It's like we do an FFT, we do an approximation, and this depends on the language. But again, this is totally dependent on the person, right? Like, it's fine. I understand that some people, they have trouble reading the Julia code, and that's fine. You know, it happens. Admittedly, the bit reverse method in the Julia needs to be updated. I'm not sure the best way to do that in Julia. And so I think actually C++, or the C code for the bit reverse might be a little bit easier to understand. Yeah, it probably is actually. The bit reverse for C is probably easier. But yeah, that definitely needs to be updated. I'll go ahead and create an issue now for all of that. Hey, Hex, how are you? Yeah, it's a good point of discussion. I would say that we should try to link to previous code. However, in the case of FFTs, even back then, this is on March 2nd. In the case of FFTs, I feel it's probably better to use a standard library like FFTW because that's what people use in practice, right? I understand that this is for convolutions, but if there's no good library to perform the operation already, then we should link to previous code. I'm not sure the best way to do that. I noticed the number of viewers dropped by 10 once Haskell code appears. That could be true. I'm not really sure. I'm not really watching how many viewers I have or anything like that. In C, we first allocate some memory. Look here. Adding C++, adding Gaussian elimination. Should we link other code? How are these related? I don't actually understand how these are related. Split up to C. Enter C, adding C++ language implementation, split operator method, Gaussian elimination, Haskell. I have no idea how these are related at all. What are we searching? FFTW? I mean, it might have just been a discussion that we had, like on stream or something like that. But I know for a fact that we had a discussion. No. I know what happened in the case of the FFT live or the FFT chapter. Now I'm pretty sure I know what happened there. I was saying we need a test, and then you guys were like, but we don't want to read in the FFTW library. And so I was like, okay, fine, just compare the two then. At that time, should it worry me that wine drops not implemented or error blah blah multiple times per second? No, it's probably okay. I used to build wine for fun all the time, so it used to take like 30 minutes to do something very basic, and it's fine. But yeah, I do think that we need to update the code. So I'm just going to go ahead and create an issue there and just mention that it looks like almost all code except for the Julia implementation, even the Python implementation. I mean, I don't understand why the Python implementation is that way. Julia is fine. C++, Clojure. Yeah, they're doing it that way too. Haskell. Yeah, okay, Julia Python. I'll just go ahead and create an issue for that then. All right, that's fine. All right, let's go up here and let's just do issues here. It should worry me. Let's see. I'm going to go ahead and do issue and say FFT. If you stealth update, this is why you started making PRs. No, I didn't stealth update anything. Like, all right, well, let's just go back to a really old version of the algorithm archive then. So we're going to do git log. I don't know, like how old should we go? We have to go way, way old. Let's just go and let's just see then. So let's go to the algorithm archive here. I mean, there's no reason to, I'm almost positive that the initial version of the FFT had a check against an actual FFT. So let's do commits. And I guess I can just go way, way back, right? So let's do older, older. What is going on here? Ah, man, someone merged without squashing. I guess elimination. Remember when you were just updating without PR? That happened like a year ago. It's been a full year since anything like that happened. Like that was back when it was Leos algorithm archive, before it was even in the algorithm archivists. So this is way old. How old are we looking at here? Let's do... No, it was more than 6 months. I haven't done that forever. Like, it has been absolutely forever ago since I did that. It's been, I mean, this was back when Let's see. Fixing the example code. Or the markup switch. Missing line of code. Yeah, this was like super long ago. Like that was before. That was like when we only had 2 chapters. That's the merge branch here. June 30th. Yep. Okay. Man, this is super long ago. Holy cow. How can I just... Maybe I can just search all commits for... Let's see, February 17th. Merge master of GitHub Laos. Adding small scale changes. Yeah, so maybe at this point... Yeah, so like maybe in February 20th or something like that. I was still updating on my own branch, but I don't think that was the case. Yeah, so it was before that. Let's see. It was 7 months ago. Open link. Oh, is that my first pull request? Yeah, okay, fine. Correct. It's weird that it was only 7 months ago, though. Oh, nope, it was way before this. It says, I've decided to start adding code and chapters up for review before pushing the algorithm archive now. Unfortunately, these chapters were already partially written. Yeah, okay, fine, maybe you're right. But it was about that time that we moved to the algorithm archivist group anyway. Adding FFT. Search. Dang it, what happened to the... Where were we? We were here. Adding BitLogic chapter. Adding new code for the algorithm archive FFT. I mean, we can just look at it here, I'm sure. This is the Haskell code. So let's just take a look at... Can we look at the browse files? Chapters, and we'll go to FFT, fundamental algorithms, mathematical background. I think I put it under mathematical background. No, I guess I put it under computational mathematics, and then probably under FFT. And then we go into code, and then we're going into FFT.jl. Yeah, even down here, like super long time ago, it's still FFT. Like I still do the approximation against the FFT method. Like it's still there. Like, I mean, we can keep going back, but I'm positive. Like the initial implementation had a check against an actual FFT library. Because I wouldn't have written the code otherwise. But I can keep going back. Revising parts of version control. Adding Creative Commons plugin. Let's see. Add blank pages to make files. Was it here? Merge pull request number 15. So this would be the 15th pull request. Let's see what we have here. So I'm going to take a look here. Let's just browse files at that point. Did we have... I don't know if we had it at this point. Computational mathematics. No, at that point we hadn't yet created code yet for it. Wait, maybe we can do coolituki.md. Maybe it's just sitting in the MD file. Oh yeah, okay. So that one was before we actually had the code directories. Let's see. Yeah, but as early as I can get to, like we had, let's see, we always had that test against the FFT library, because again, whenever I write code, I always check it against something. So the merge pull request master, yeah. So somewhere back there, like, but again, that was like super long time ago. Different license, merge pull request, adding fluff to version control. Let's go to newer. I don't know where it'd be, but somebody small scale changes to FFT chapter. We'll add butterfly diagrams. Let's see. Oh, sweet, 2017. But basically, before anyone else implemented anything in the algorithm archive, or any other FFT method in the algorithm archive, I know for a fact that test was there. So I guess what happened, still believing C++ is a cool language? Yeah. Oh, this is probably it. Changed FFT directory and added example code for Julia FFT. Function main. Okay, so you might be right, because down here, here we have the Julia code, and you're right. Down here we didn't have a check. We do have an approximation, but I just didn't put the check in there yet. So it looks like this guy. Length indices. Loops. Wait, where is it? So you might be right in that the initial... Let's start. You can create a time capsule. Adding rough draft, adding edited FFT chapter. Okay, so let's see, what do we have here? Adding edited FFT chapter. Yeah, so by the time the FFT chapter was edited up and ready to go, which is here, the Julia implementation had the tests in it. And this was... That was before we even had a code directory for multiple different code snippets. Adding new code by GA in the algorithm archive. C++ FFT. Yeah, okay. So I think I know what happened. What did you say I was? I don't think I said you were anything. Why is one commit named P? I don't know. Let me see. I have no idea. This is a super long time ago, man. I don't know what this one is. I'm sorry. That must have just been an error on my part. I don't know what happened there. That was a mistake. That was a long time ago, though. Jeez. Okay. Oh, yeah, you might have been right. Okay, so here's, I think, what happened. As I was editing and updating the FFT chapter, I didn't have that test in there initially, but when the chapter was completed and it was actually put onto the algorithm archive as something that people could contribute to, at that point it had the test in there. And so I think before anyone actually implemented any code, besides the Julia version, I think it did have the test in there. Does that make sense? So like back when it was just the pseudocode weird Julia thing that I had like a year ago or a year and a half ago or something like that, there wasn't obviously a test in there because it was just kind of pseudocode and it was fine. But then once we added the Julia code in there, I added a quick implementation, and then by the time the chapter was edited up and ready for people to submit code to, it was the test was already in there. So this is way back in 2017, like long time ago. Now what could have happened was it could have been that in that time while we were updating the Julia version, it could have been that you took an older version before the FFT was actually implemented correctly, and you took that to base your stuff off of. Like that could have happened. And so maybe we're both right in some ways, but I do know for a fact that when the chapter was up and like it was ready for people to submit code to, the test was there. I remember writing before you had the code up. I mean, that could be true then, because that could also be part of the thing here. But regardless, I know the test is there, and I know the test should be there. And the fact that it's not there is actually just means that I've not been paying any attention to what people have been doing for the FFT reviews and stuff like that, because I really should be paying closer attention than that. Or else I was too relaxed on that. So regardless, we know that we need to have the test in there. Like I think no one's disagreeing that we need the test in there now. So let's go ahead and do issues here. I'll go ahead and create a quick issue. I don't know if I should create the issue now or after the FFT chapter has been updated. I feel like maybe I should do it after the FFT chapter has been updated. Yeah, I think that's also what happened. I think people just, they were looking at the C code instead of the Julia code. And admittedly, again, I think the bit reverse stuff for the Julia is a bit weird, right? Because we have just the bits. Let me see. Let me take a look at the FFT. And let me take a look at the Julia version here. So for the bit reverse, I literally just, yeah, this is probably a Julia specific thing, right? Because I basically just took the bit indices here. So, and they have this. Yeah, no, I guess they don't have the bits function anymore, so I think this has changed. Missing algorithm implementations? Yeah. Just add it there. Yeah, you're right, I can add it here. Here's a list of all the incomplete, partially complete language implementations. Yeah, so I guess we'll just add them all here. So let's go ahead and do edit, and we'll say FFT, and we'll go ahead and add them in here. So we'll say C, C++, Python, let's see, FFT, what else do we have? I guess it's Python, Haskell, Clojure, and Scratch. 1, 2, 3, 4, 5, 6, so there should be 6 total. Let's see, where are we? We're over here. So then we need closure. Haskell. And then the last one's Scratch, which honestly will probably not be updated. Okay, let's go ahead and update the comment. And I should also mention here what these are. So let's go ahead and edit this. Adding against actual FFT libraries. Okay, nice. Yeah, it's there. I should probably at least put it down. Let's see. Cool. All right, so we've got that kind of working. Sorry about that. That was kind of, we kind of got a bit derailed there. Let's at least get one visualization working, and then we'll go from there. For the FFT method. So again, that was just a discussion about the FFT chapter in general. The FFT, so for the record, I totally and completely admit that the FFT chapter needs heavy revision. And it was one of the first chapters that I wrote for the algorithm archive. The Gaussian elimination was the first chapter. I think the FFT was the second chapter or something like that. And back when I initially wrote the FFT chapter, I'm going to be totally and completely honest. You didn't get a notification because I just updated the comment. But I can also mention here and say, I just... the previous list to include information about the FFT chapter that is currently undergoing revision. Basically, all of the implementations besides Julia do not have an appropriate, appropriate, there we go, test against what am I saying here? An appropriate test against an actual FFT library. Okay, as a note, maybe you guys should maybe wait a week on this until after the revisions for this chapter. Okay, just quickly noticing that. Okay, cool. So let's go back to the FFT visualization. So we have the FFTW library, so we should be able to just go up here and just say, quit here, cd into projects, Simulayos, and FFT. We should be able to do a quick FFT b equals FFT of a. Yep, seems to work. And now we can just plot. I guess what I'm going to want to plot is the abs squared of b. Abs 2. What? Is it going to be abs 2 of b? How am I not able to do that? Abs 2. Why am I not able to do that? Is there a dot in there? Okay, there's a dot in there now. That's good to know. Okay, I don't know why the dot exists. Okay, so this is kind of nice, but it's not exactly what we want to see. So the frequency that we're looking for, because we have a sine wave from 0 to 2 pi, the frequency that we're looking for is basically 1. So we're going to, the problem is after performing the FFT, we do have a frequency that is at about 1. But it's not quite what we want to see. So let's go ahead and let's change this so that when we were initially creating A, we only do it from 0 to 100. And then what we want to do is plot at, well, set B equal to FFT of A, and then say plot abs squared of B. But we only want to plot a certain number of elements. So what we're going to plot is plot abs squared of B, and we want to plot just from 0 to, ding notification, 8 complete. What do you mean 8 complete? Oh, I must have misspelled something. I updated the previous list to include information for the FFT chapter. Basically, all information I have. Yeah, okay, I'm sorry, I made a typo. I will edit this up so that we don't have the typo anymore. Okay, update the comment. Okay, so let's go. So I want to grab a certain subset of the B matrix that we have here. Now I don't really remember how to do this in Julia. I know it's super easy. I just don't remember. So I want to say I'm just going to grab 1 to we'll say 50. Yep, that's what I want to see. Okay, so what we can see here is that if we plot the sine wave, so we're going to also plot plot A. Where is it? Plot A. So here's our sine wave, right? And this is just one frequency. It's not very difficult to see. And here is our here's what happens after the Fourier transform. So we have one peak at 1. Now what we do is if we change A a bit, so let's go ahead and change A over here so that it equals maybe 4 times pi. So we're doubling the frequency here. So we're going to say 4 times pi, and then we're going to plot A again. We see that the frequency is twice as much. And we should also see when we plot ab squared of B after performing the Fourier transform and then plotting ab squared of B, we should see, we should see that this peak has moved slightly to the right. And so basically as this frequency increases and decreases, as we have like a higher frequency, this peak will start shifting left and right. And that's basically, in my opinion, the easiest way to understand what a Fourier transform does. It takes something that is in real space, some sort of really complicated wave in real space, and then moves it into frequency space where it's basically just a single peak, and it makes it way, way easier to understand. And that's essentially the Fourier transform. It's just moving something, some complicated mess of waves in real space that you can't really understand, and moving that into frequency space where it's much easier. So for example, let's go ahead and add a couple of these guys together. So I'm going to say 8 times pi here. And I'm going to also say we're going to have some element C, which is going to be equal to 2 times pi. Yep. And now we're going to do A is going to be equal to A plus C. Okay. And now we're going to say B is the Fourier transform of A. And we're just going to plot this guy here. Okay. So what I did is I added 2 frequencies together. I added 8 and 2 pi together. So basically I added 2 different sine waves together. And if you plot the 2 sine waves together in frequency space, you'll get 2 defined peaks. But in real space, if we plot A, it's some sort of weird mess of waves that's really hard to understand, right? So I don't really understand what the 2 frequencies are. I just know that there are 2 frequencies added together here. And when we plot that in Fourier space, it becomes just 2 defined peaks. And so again, we're kind of making this sine wave way easier to understand. So let me just go ahead and add a few more frequencies on top of this. So we're going to say C is going to be equal to, we'll say 12. I don't know. And then we're going to say A is going to be equal to A plus C. And so we're adding in another wave on top of our sine wave. So again, if we plot A, we get some sort of weird mess of waves. And if we plot B, we get 3 peaks, right? So now it's clear what these 3 peaks are. And these are peaks at 1, 4, and 6, which are corresponding to the frequencies of our system. So again, we can increase, we can have like super high oscillations here. So we can turn this to, I don't know, let's say, I think 100 is about as high as we can go with this resolution. Well, let's just do 100. Let's see what happens. So we're going to do 100, and then we're going to do A is A plus C, and we're going to do plot A. So here's our new wave. It's like some sort of crazy mess of waves. I don't know what's going on there. And if we do B is equal to the Fourier transform of A, and we plot B, we get, well, okay, the last peak isn't there. I don't really know where that peak went. But anyway, we'll kind of work with this animation, and we have a lot of stuff to go off of here. So what I want to do then is I want to take this and I want to basically create a plot with time. So I want to make it so like as we move one frequency, we make one frequency bigger and smaller. So we increase the sinusoidal oscillations on one. We see the peak and frequency space move. Real space sounds a bit confusing to me. So it implies that frequency domain is not real. I've always heard it referred to as time domain instead. Yeah, so that's it depends on what you're doing here. To be totally and completely honest, when I say, I don't know actually the best way to describe this actually when I think about it. I guess you're right, maybe time domain is more correct. It's just I've always heard of it as real space and frequency space. But this is because again, when I do it, I'm usually doing this. I'm usually doing the split operator method. And here it does have a clear physical interpretation, as in you have something in real space, you perform the Fourier transform and it moves it over to momentum space. And momentum space is just 1 over it's the frequency space for how do I put this? it is the frequency space for like physical objects, if that makes sense. So it's like 1 over length. And so again, it's kind of moving from some object in real space to some object in, again, momentum space, I guess is the more accurate way to put this. But also, I guess, is more position in momentum space. I'm not sure. It's kind of, the whole notation is kind of confusing depending on who you ask. As far as the time domain and frequency domain, it's more like the physics community has a different name for it. But again, that's because the Fourier transform, it doesn't necessarily have to be across the time domain, right? It could also be across the spatial domain, whereas, again, you move from position space to momentum space. And I tried to make sure here in this particular visualization, I tried to make sure we were talking exclusively about position space and momentum space, because I wanted to make sure that I didn't say the real, like I didn't say real space, you know? So I do, again, I need to update this anyway, so I need to stop saying real space. But it sounds weird to say time, you know, like, I don't know, time domain just sounds weird to me. It's not something I'm used to hearing. Xrun M2, hey, how are you? I'm glad to see you back. So again, the Fourier transform allows us to move from position space to momentum space, at least for quantum systems. So this is something that's also very important to keep in mind. Okay, so let's think. So let's just go ahead and get a quick animation running, and then we go from there. I don't listen to engineers. They don't know math. They call IJ. Like fools. Actually, I don't know why they call IJ. Actually, I've never really understood that. You know, like, why in an engineering community would you call a complex number a J instead of I? You know what I mean? Time, space, space, time. Okay, so I'm going to go ahead and just keep working on this animation here. It shouldn't be too complicated to do because, again, we already did something very similar before for the split operator method. So we'll just be grabbing kind of similar stuff over here. So let's go ahead and open up a new terminal, and I'm just going to cd into the appropriate directory. So we're going to cd into projects, Simuleos, and FFT over here. Coding with ethanol, oh my word. I think Gathros was making a joke for the record. Like I'm 90% sure that was a joke. Okay, let's go ahead and clear here too. I'm going to go ahead and open up a new file, which we're going to call FFT. I guess we'll call it animation.jl. And in here, I'm just going to do using plots and using FFTW. I believe it's like this. Okay. So what do we actually need to do? I guess in principle, we don't need to do too much. We just need to basically create variables that correspond to the FFT and correspond to plotting like a real space variable. So we're going to say plot real. Okay, so again, maybe we shouldn't call it real. We should call it, I guess we'll call it plot frequency. And you're saying we should call it time. Is that actually correct? Yeah, I guess it is correct. Yeah, so I guess it's plot frequency and plot time. So what value should we have in here? We should read in, let me think. Okay. So for this guy, let's see, what do we have here? I feel like something screwed up. Fat32, I win? What? I don't understand. What happened in the chat? JSP is trying to stop the fighting, but I'm a mod, so it'll just become an unfair battle? Whoa, wait. Did something happen? Did something happen here that I missed? Now it's clicking buttons. I thought you were against Super Saiyan coding with ethanol. I have no idea what happened. I have no idea what happened in the chat. Enabling follow only mode by accident. That's fine. I'm so sorry. How did I set up split screen console like you? What do you mean, how do you set up a split screen console? So I literally just have a bunch of terminals that I'm just opening up. So I open up a bunch of terminals and just plot them as need be. So I've got a few commands that allow me to just like move terminals to certain locations. So like I can just move them around a bit, but ultimately it's ultimately there isn't much more than that. I just have a few keybinds to just move terminals around. Here I am moving a terminal around. Whoa, look at this crazy desktop. Okay, let's keep going. Okay, so we're gonna have plot time and plot frequency. So I guess we'll do the plot time first. So we'll do plot time. And what do we need to read in here? We probably need to read in a resolution, which is going to be an int64. What else do we need here? Resolution of the plot itself. I suppose we want number of time frames. So I guess we're going to say time steps. which I'm just going to call time steps here, which again is going to be an int64. Okay, how many more time steps do we need? What type of frequencies do we want to go through? Maybe the number of sine waves we're going to be working with. I'm not really sure. Lots of stuff to work on there. I'm converting to Linux tomorrow. Oh, nice. It's so much more responsive when I get my ThinkPad. Tiling Windows managers are a meme. Honestly, I know a lot of people that really like tiling Windows managers. It's not super uncommon. I think a lot of people like tiling Windows managers they're nice, you know? Like I know a lot of people use Awesome. I know a lot of people use what is it? Oh my gosh, what is it? The IW3? Is that what it is? Anyway, a lot of people, they like tiling Windows Manager. It's fair. Windows moving around like crazy. What is this? Ubuntu? No, it's Arch. I'm better than Ubuntu. There was a video I saw yesterday about like some guy talking about the #1 best Linux distribution of 2018. And he was like, it's Arch. And I'm like, yeah, of course it's Arch, because Arch is the best. You know, I hate to say that I'm biased, but I am quite biased. You can get something like that with AutoHotkey. It's not a tiling Windows Manager, but it helps you lay stuff out quickly. Yeah, that's basically what I have here. What happened to Xrun when I get my ThinkPad? Oh yeah. I'm hoping that you enjoy Linux. If you have trouble with it, just please feel free to go to Discord. Come on, I can spell Discord. Please feel free to go to Discord and just ask for help. It's kind of nice. The thing with the programmer community, it's like, I'm super interested. What's the programmer community like? Have something that works. Let me get some quick water over here. What else did I miss over here in chat? I think it's just discussions about how Linux is better than any other operating system in existence, which is, of course, true. Like, there's no doubt. I hear Arch is bare bones, so it's customizable for your preferences. That's basically it. The way I see it is Arch has, in my opinion, it gives you the ability to install whatever you want to install, right? Like as you're doing the installation, you basically see all the packages that you're installing on your system, and you basically say, yes, I want this package on my system. So you build it from the ground up. It is in some sense a bit more bare bones because you've got to build everything from the ground up, but you get a very good understanding of what is actually in your system. So if you ever have questions about what's happening or why something's happening, you know because you did the Arch install and you put the appropriate packages in your system. It gives you the full scope. You fully understand all the problems with your system because you were the one that installed ALSA. You were the one that installed Pulse Audio. You were the one that installed NVIDIA. You know what's going on, you know, and that's very nice. That's the reason I really like Arch, because you get a very good understanding of your system. And that's something that a lot of other distributions just don't provide. And being totally completely honest here, I do understand that, you know, being an Arch Linux user is a bit of a meme. It's like, oh, I use Arch, by the way, but it's nice. You know, Arch gives you a lot of advantages that others don't. And as far as what Coding with Ethanol is saying, Arch is the best, but sadly Windows is so much ahead in games. That's true. If you're going to be using Linux for gaming, you're going to be taking a hit. You could be using Wine, like JSBP was saying earlier. It's fine, Wine works, but ultimately you're going to be running into some issues here and there with gaming on Linux. And if gaming is what you want to do, stick with Windows. If you want to use Microsoft Word, you want a Linux terminal, go with Mac. If you really just like Linux it's for you. I like Linux. It's amazing. Let's see. I missed some stuff up here. Coding with Ethanol. Make a version which is harder to use and has less functionality, and then praise it. I don't know if I agree with that. I think I understand what you're trying to get at. You're trying to say that Arch, assuming that you're talking about Arch, you're trying to say that Arch is harder to use, which is probably true. And then you're saying that it has less functionality, which I disagree with on a fundamental level, but I also understand, like what we were saying before, you can't use as many games on it and stuff like that. But for me, Arch has way more functionality than Windows does, because Windows doesn't have a Unix terminal. I can't do anything without a terminal. So like having a computer without a terminal is completely useless to me. It's just, why would I even have this machine, you know? And that's kind of how it is, you know? Now Macs are a good middle ground. I will say that I do very much enjoy working on Mac systems when compared to Windows systems, because Macs, at the very least, you have access to a Unix terminal, but you don't have a natural package manager. So it's still kind of like, where is that functionality? I need my package manager. I need the ability to just run Firefox in the terminal, and for it to have, like this, the fact that I just run Firefox and it pops up, that's amazing. That doesn't work on Mac. That doesn't work on Windows. There's some things that I like doing, and I just can't do on Windows or Mac. And so that's why I like Linux. It gives me the functionality I want, you know? And that's kind of how it is. Yeah, but okay, to be fair, maybe you know a trick to get it to work on a Mac. but I don't think it works on the Mac systems that I did without specifically creating an alias for that particular particular command. You know what I mean? It doesn't pull up a UI. Open-A Firefox. Okay, fine. I didn't know about that. I appreciate that. Thanks for letting me know. Okay, what do we have here? Make your own CPU, make your own OS, find software library for it, and software library for it. Arch is good if you know what you're doing. That's true. KVM, QEMU, I use Tails. I don't know much about it, Tails, if I'm being honest. So require a big upfront investment to learn your tool. Yeah, but at least you know your tool, you know? My first encounter with Linux was messing around with Gentoo in a VM. Ooh, that sounds harsh. QEMU is pretty awesome, by the way. Sadly, not too useful on Mac. I also use Fedora, and while it's not as popular, it is not Ubuntu. Yeah, I guess that's fair. If I missed something in chat, I do apologize. JSBP Looking Glass. What? Oh, I don't know this one. Let's see. YouTube.com. Let's take a look. Open-A Firefox. Open link. What do we have? Looking Glass. Oh, okay. Yeah. I've heard of this, but I don't know what it is exactly. KVM Looking Glass demo, gameplay of Elder Scrolls Skyrim. Yeah, I don't know much about this at all. Let's see, my friend jokingly recommended Gentoo to me, but I didn't notice the joke. Oh, Gentoo's quite hard. I can just run separate OSs on different drives and swap them. Yeah, I used to do this on my old computer. So I took out the CD drive of my old computer and put in a hard drive for it. This was a laptop. And then I had the CD drive, hard drive. The hard drive that was in the CD drive, that was my Windows partition, and then my main partition was my Linux partition. I accidentally deleted my Windows partition just because I was busy messing around with data and stuff like that. And I didn't even notice it was gone for like 4 months, and that was my final decision. I was like, look, if I didn't even realize that this Windows partition was gone for 4 months, I might as well just get rid of it. You know, it's not worth having. It's just a waste of space, you know? Let's see, Open-A opens the current folder in Finder. Oh yeah, that's quite nice. Let's see, how about just a double-click shortcut? Then you don't have to type anything. But that's the thing, I like the typing. Like, don't get me wrong, like, I understand that a lot of people really like UIs, but I'm someone that always misclicks. I always have trouble with UIs. Like, no matter what, if there's a UI in front of me, I just can't use it properly. But if I have a terminal interface, a CLI, at the very least, you know, I know I'm not going to do something dumb. You know, like, you can mistype something fine, but there's man pages to figure out what you're doing. Like, I just feel more comfortable in a terminal than I do in a GUI. Like, 10 times more comfortable in a terminal. And that's just my personal preference. I do understand this, but I very much prefer having a CLI to a GUI. And this is my own personal opinion, but it is what it is. I'm a casual Linux user. I program a little, but not much. Mostly just browse the web and watch some movies and TV shows, but I still like Arch. Although I don't use pure Arch, but Manjaro still works for me. Yeah, Manjaro is great. Manjaro is honestly one of my favorite user-friendly Linux distributions that are out there. I really do enjoy it, and I think that more people should use it. I've used Ubuntu before, but I prefer Arch right now. Look at the start. Look at the start. Looking Glass is an open source application that allows the use of KVM kernel-based virtual machine configured for a VGA PCI pass-through without an attached physical monitor, keyboard, or mouse. Oh, that's quite useful. This is the final step required to move away from dual booting with other operating systems for legacy programs that require high performance graphics. So, okay. Yeah, I can see how that's useful. I've definitely wanted something like that before. Let's see. I was thinking about doing that. Getting a feeling 2 drives makes overall weight heavier. I don't know. It was fine for me, but it depends on what you want. Simulos correction opens current folder in the terminal. No need for -A there. Oh, okay, nice. It's a KVM with dedicated GPU to play games on Windows. Then it takes the frame buffer and puts it on screen on Linux. Okay, I see what you're doing. By any chance, do you know how to open a Visual Studio Code from the terminal in the current folder? On Windows, I just type code, but on Mac, it does nothing. Yeah, I have no idea. I don't use Visual Studio Code. I agree with the CLI over GUI argument. It's annoying to have to constantly move one hand between the mouse and keyboard. Yeah, I agree. There's a lot of reasons why I like CLIs. It's just, I like command line. I don't know why, but this is aesthetically pleasing to me. I just like having a bunch of terminals on screen. I can't explain it. It's like when you look out at the ocean, it's like, the ocean is beautiful. Yeah, of course it's beautiful. It's the ocean. It's the same thing here. When I look at this, it's just so mesmerizing. You know, I love looking at just a bunch of ASCII text. Just, you know, it's just so cool. And I guess that's the reason I like Arch, because, you know, the first thing you see when you open up Arch is Arch ISO login, you know, and you're like, man, that's so cool. Like just having a full screen terminal, then that's how you do your installation. It's just so cool. Like, I don't know, I don't know. I can't think of anything cooler than just a full screen terminal, and just hacking away. I don't know why, it's just cool. Let's see, what has an external GPU? Let's see, terminal is great for scripting and automatically batch jobs, but that would take forever to perform a GUI. This is true too. I mean, there's advantages to using a GUI too. Like, don't get me wrong. Like, I obviously use an internet browser. I don't use E-links too. But you know, there are things. There are pluses and minuses to everything. Pretty stoked to learn Linux. Yeah, but don't put all your eggs in one basket. Like I said before, and like coding with ethanol has been explaining and stuff like that, everyone has a different way in which they want to use their computer. And if Linux isn't the way you want to use your computer, I totally understand that, and I'm not going to say that you're wrong for doing that. I'm just saying I like this. I like everything about Linux. I like everything about Arch. I like it. It's nice. But that doesn't mean you have to like it. You do what makes sense for you. If Windows is what makes sense for you, if Mac is what makes sense for you, do that. Like, I don't care. Like, I just happen to be a big fanboy. That doesn't mean that I'm against any other fandom out there. Operating system fandoms, that actually maybe is probably a thing, but I don't really want to go too far into it. I feel like every coding stream or discussion devolves into OS wars. Again, this isn't a war. I'm just like super excited, you know? Like, Windows annoyed me to no end. Again, like, so you're not a real fanboy? Maybe not. Let's see, what do we have here? Coding with ethanol. Let's take a look. Which computer has dual GPUs? My computer has dual GPUs, but I mainly use GPU computing. For many individuals in the herd, it is considered prestigious to not utilize this unit at all. I know this. I've seen that before. It's pretty good. I feel like every coding stream or discussion devolves into OS war. I'm loving the low latency 30-second buffer. I'm glad that it's working for some people. I think for some people it's not too much better. Let's see. What am I doing here? Not a big fan of VMs. They always overallocate resources. No, I'm like, thanks Windows. Thanks for Thanks for the shadow program forcing me to update Windows. It is what it is, you know? Like, I'm not gonna... Windows has its uses. I mean, there's a reason 95 or whatever % of desktop users use Windows. It's useful. It's nice. It's easy, you know? I don't know what the percentages are. We can look up desktop statistics. Desktop OS statistics. I want to say it's like 95% of people. Desktop OS market share. Yeah, so let's see. This is for July of 2018, and it looks like Linux is... Oh, actually, that's a bit different than what I was expecting. I don't know. I mean, I don't know how much you trust Statistica, but, you know, it says we have macOS being 12.52%, Linux being 1.71%, and Windows being 82.88%. That's actually significantly lower than I was expecting. So that's kind of nice. Windows market share is too high. Linux is rising. It probably is rising. I mean, let's see. It was 0.88 and in 2013. Let's see. It's been steadily rising, I guess. Yeah, steadily rising, I would say. But it's still, you know, no more than 2% of the market share, you know? And that's fair, you know? Yeah, boys, we're at the top 1.71%. We made it. At this point, I think it's monopoly to keep a monopoly keeping care of itself. Oh, as far as Windows is concerned, yeah, that could be true. Mac is quite high, to my surprise. Chrome OS looks to be doing okay. Yeah, I mean, it's okay, you know. Oh, actually, Chrome OS is doing quite okay. Well, it was at some point, 1.22. That's quite high, but then it seems to have dropped to 0.5. I'm not really sure what happened there. All the videos I saw lagging. But if we consider mobile devices, though, this is true. If you consider supercomputers, like literally every supercomputer in the top 500 uses Linux. 100% of all supercomputers in the top 500 supercomputers use Linux. Like, Linux has its advantages too. I understand it might not be desktop advantages, but it has its advantages in HPC computing. It has its advantages in a bunch of other areas, you know? Like, again, admittedly, there might be problems with, there might be problems here and there with Linux, and I totally understand, and I'm not going to sit here and argue that it's somehow better, but I will say that it's nice. By the way, Linux is not the most used OS. No, I know it's not. Now, when big tech companies die, Linux will be first. I mean, I don't know. Why send your personal data to Google directly then? Why not send your personal data? Other than some game compatibility issues, there's nothing I can do on my Windows machine that I can't already do in Linux. Yep, this is true. I mean, except for the software compatibility, I do agree with you. I think pretty much everything else can be done on Linux. Okay, so let me... See, now we only have 15 minutes because I've been sitting here rambling about operating systems the whole time, which is fine. Don't get me wrong. I like operating systems. I like rambling about operating systems. Whenever I can show my fanboyism towards Arch Linux, I mean, look at my wallpaper. Of course, I'll do it. But yeah, we're kind of behind. So let's try to get at least one of these animations done, and then we'll go from there. L4 is the most used OS. Every board chip has an L4 OS on it. I don't know what that is. I mean, every Microsoft employee doesn't really care. Don't really care about Windows that much. Look at Visual Studio Channel. It doesn't take long to find a non-Windows device. Yeah, I guess that's fair. So that's also a factor when you switch to Linux. Look at me typing from Hex Chat. That's amazing. Let's see. OS Talk. I would consider Android a spyware. I don't know. I mean, like, just as much as any operating system is spying on you, besides potentially Linux. L4 is short for Linux, I think. L, right? For L in Linux, and then INUX, which is 4 letters. Linux, you're correct. All right, plot time. So what else do we need? So we want time steps, we want resolution. I guess that's all we really need here. So we're just gonna go ahead and do end here. And what I'm gonna do is I'm just gonna create an array, and we're just gonna plot this array out and go from there. It shouldn't be too difficult to do. So we're gonna say A is going to be equal to, like we said before, it's just gonna be some sort of sine wave of 2 times pi. And it's going to be times, I guess it's going to be times I divided by time steps. I'll define I in just a second. 2% I times pi over time steps. No, 2 pi times I over time steps. And this is going to be, wait. We have to do spatial steps too. So now this is going to be, 1 second. Let's do this. There, and it should be I times j divided by time steps, and we're gonna do time steps times resolution. Okay, so here we have basically 2 loops, and the idea is that we're gonna be going through, we're gonna be changing the frequency from basically 0 to 2 pi, but actually we should probably change the frequency from, 2 to like just increasing, right? So we should do it from 2 to like 100 or something like that. So we'll do 2 plus, let's do 32 times I over time steps, something like this. So now we're gonna delete these guys and this guy in here. And this should be correct mathematically. Yeah, that should work. And so I guess we're just going to do, for j in, j equals 1 to res for the spatial resolution. And I guess we can do for I equals 1 to time steps. Maybe? We'll see what happens. No, does that make sense? Why are we doing a 2D array? Why would I do it that way? That seems dumb. I'm not going to do it that way. What am I, an idiot? Don't answer that. For I equals 1 to time steps. End here. So here's our A that we're going to be plotting, and this should be fine. Yep, that should be fine. So now we have our A. All we have to do is plot this every time step. So what I'm going to do is I'm just going to pop down here and say plot A. Go over here, and we're just going to run in our Julia shell over here. Include. What is this called? Animation. Let's go. Res not defined. What? Oh. What? For j equals 1 to resolution. I screwed something up. I call it OS Wars because it's a meme. This discussion has been had to death millions of times over message boards, Reddit, Slack. Yeah, that's correct. I mean, but it doesn't mean that it's not interesting. It's like discussions about text editors and everything like that. I mean, it's a meme for a reason. People enjoy talking about this kind of stuff. It's fun, you know? Like, it kind of tells you about a person. It's like you know, you don't get bored talking about your favorite video game. You know, if people talk to me about Guild Wars or Super Smash Brothers, I can go on for hours and hours and hours about these video games. He put the IO, an idiot. But yeah, it's the same thing. Like, people just go on hours and hours and hours talking about their favorite OSs because they genuinely like their OSs. You know, it's the same with video gaming. You know, like, I'll go on for hours and hours and hours for why I like these games because I like the games. It's the same thing. If 5 you might switch to Mac if you need it. True. I mean, I've used a lot of Macs before. So plot time, int resolution, time steps, res int64. What is going on here? What is your deal? Says line 4. The heck? Okay, I know res is not defined. We'll do resolution of 100, and we'll do time steps of 3. I'm really confused here. Am I just doing something incredibly dumb? Resolution in 64. What on earth? Did I just forget how to write Julia code all of a sudden? Coolituki X. Okay, well, let's just... What? Did I just forget how to write Julia code? Plot time not defined. Oh, that's why. I did forget how to write Julia code. Oh my gosh. For I equals 1 to time steps, plot A. It doesn't like this guy. For J equals 1 to resolution. I think that should be correct though. Oh, that's because I did it wrong, I think. No. Ah, shoot, let me... That's what I should be doing. Alright, let's try this again. Ho ho, look at that. I didn't show any of the plots. Let's do 103. Dang it. Gah. Let's go to FFT microchip, which just does everything digitally. Yeah, this is fine. Agella's group, hey, how are you? Let's see, but without Google services, in 5 years you might switch to Mac if you need it. Very reasonable, lock down Google free, Android, iPhone, dumb phone. Wait, what? I'm so confused. Oh, okay, alternatives to Android, I guess is what we're saying. No need a phone, so dumb it is. What editor is that? I'm using Vim. Actually, technically, I'm using VI. Yep, that is true. Kelly's group, you could do that with an FPGA. Ooh, FPGAs are super interesting. I really want to do more with FPGAs. Like, at some point, I just want to just everything. I want everything to be FPGA. But, like, I know that's not going to happen. But I wish I could just do everything in my research with FPGAs. They're so cool. I used Emacs for a bit. It's fair enough. Good luck coding for an FPGA. OpenCL does it pretty well, I think. FPGAs aren't hard to use, to be honest. FPGAs are costly. Are they actually that costly? I'm not sure. I know I can get them for my university without too much trouble. Okay, let me do show. So we plotted A. I guess what I'm going to do, I'm just going to open up this guy over here, and let's just go into vi split operator method, and I'm going to look for, no, I don't look for any of that. Don't give me that, no. Split op.jl, and I'm just going to look for where I output the images. So it looks like I output the images here. So basically I have plot, x-axis 4 times density, label wave function density. Okay, so I did a lot of things to the plot. Trapping potential plot here. So what happens if I just do, oh, I see. So we have save fig. So I want to save the figure. So we're going to save fig. And we're going to call it, what should we call it? We're going to call it time. And I guess, yeah, we'll just call it time. Time underscore, and we're going to do concatenated with string of lpad of I minus 1. Yep. And we'll do, let's do 4 zeros. And then we should string lpad. Yep. So now we're going to concatenate that with .png. Okay, so let's pop over here, back to the Julia shell, and we're just going to include FFT animation one more time. Load error, no matching LPAD. What is LPAD in then? LPAD. What am I doing up here? Using plots. LPAD. String LPAD. Where is it? So to lose without modern tech, like car? What? Neo-Luddism or New Luddism is a philosophy opposing many forms of modern technology. The word Luddite is generally used as a derogatory term applied to people showing technophobic leanings. Are we talking about like Amish people? I like Amish people. Amish people are quite nice. There is ways to create an FPGA design from a compiler that does both hardware config and compile code to run on the FPGA. Yeah, I think so. I mean, don't get me wrong, maybe I'm wrong here, but I know that OpenCL can work on FPGAs, so I'm not sure exactly how they do that. Why does the LPAD command not exist? Huh. Okay, well, let's look up LPAD Julia. Let's go. Should be a, okay. LPAD person. Printline person is, why does LPAD not exist? All right, let's try this again. It says no method matching LPAD N64 N64. Oh, okay, wait a minute. I think I just put this in wrong. LPAD. Nope, I have no idea what the problem is then. I-18. Okay, let's take a look at LPAD. Abstract string. Oh, wait. I think I did this wrong. So it should be... I don't know what I did wrong, actually. I have no idea. LPAD of 0... Does it need to be a string now? I don't know. Who buys FPGAs over usual math chips is heavily overpaying if he isn't buying it for one-time research. One-time thing, it's cool. But when thousands of chips are coming, and efficiency per buck is a question, but it does fall off heavily. Nobody can buy FPGAs to build a computer. Oh yeah, okay, I do understand there. Mainly for my research, like I'd like to use FPGAs, but this is also totally fair that, you know, you aren't going to use it for bulk. I guess you could say, not bulk computation, but bulk engineering or something like that. I don't really know how to put this. An FPGA is a field programmable gate array. It's basically, and again, this is something, I don't know so much about this. I've been wanting to use them, but I don't know much about them myself. But FPGAs are basically like, in a way, you are compiling hardware when you do the compilation. Like, I don't really know how to put this. Someone in the chat can actually better describe this, and I'd be very interested in your description. But it's good for like sparse arrays and stuff like this. I don't know the best way to describe it, if I'm being honest. An FPGA can be configured to run OpenCL, sure, but if you want an FPGA optimized for a specific algorithm, this is true. It helps to cover both FPGA code and executable code. Though I've only tried Xilinx's own one. I don't know if they have any open source ones. Yeah, so someone in the chat, feel free to give a better description of FPGAs. Like, my understanding now is that, like, you're basically manipulating individual circuits within this device that you can slot into your basically GPU slot. And this allows you to kind of get more finesse into your compilation. Like you can better finesse your programming such that you can speed certain computation up, particularly sparse computation. But I don't know, just like a good description of what an FPGA is, I guess, is kind of what we're looking for right now. Because again, my description is pretty bad. Okay, I-1, 8, 0. Okay, well, let me just look up the LPAD command, Julia. So it says integer p abstract string. So maybe what I should do is change this to a string that is 0. Okay, that one seemed to work. So let's go ahead and pop over here, quit, ls. Ah, cool. Okay, so let's do a quick mirage of time, time 000.png. 1, 2, 3. Okay, that wasn't quite what I was looking for. Okay. Let's try this again. So we're going to do j divided by resolution. I think the issue here is that we're accidentally doing integer division when we want to do non-integer division. So let's do, I'm going to interpret this as a float 64 here. And I want to interpret this as, oopsie, let's try that one again. I want to interpret this as a float 64 over here. Okay, so let's try that one more time. Mirage time. No, you're still screwing up, man. Man, what on earth? Why? Ah. Plot A, sine of 2 float 64 of I divided by time steps, times pi times float 64 j divided by resolution for j equals 1 to resolution. Bah, I don't know what the deal is here. Okay, Gales Group Tesla did evaluate FPGAs. Let's see. I think some version of the Tesla AP board shipped actually do have FPGAs to replace the ASIC Mobileye. This is a good description. An FPGA is literally a programmable digital circuit. Yeah, this is what I was expecting. An FPGA is like having an efficient access to parts of your device as needed. Yeah, okay. I'll buy that. An FPGA is a chip with a ton of lookup tables used to simulate logical gates. Yeah, okay. Like an ASIC, it's customized hardware with lower speed and cost and reprogrammable. Yeah, I think this is... That right there, I think, is the best definition we have for an FPGA. But again, honestly, I would love to be able to do FPGA on stream, actually. That'd be kind of nice. I would love to be able to do that. Okay, let me see what I'm doing wrong here. I have no idea what I'm doing wrong. A sine of 2... Oh, maybe I need to do 2... We need to multiply this by pi? Let me try something here. So I'm going to do this, and I'm going to multiply this by times pi. Okay. Let's try this. Let's go over here, and let's just include the guy. Mirage time. Ha! Whatever this is, that is still wrong. Come on, dog. Give me something. Did I forgot? No, it's sine. Times pi. Divided by time steps. Oh, I think I screwed up here. That's where I must have screwed up. Let me take a look at something. A is going to be equal to sine 4i. Yeah, I think that's what I screwed up with. Let's go ahead and move over here. Let's not multiply that by pi. Let's get rid of that guy. And that guy over here. Oh, no, actually, we want this. I think I know what I did wrong now. And then we want this to end divided by time steps. No, that was correct before. So we want 2 plus 32 times float 64 divided by time steps. But we want this to be here, and I want this to be there. Let's try this. There's our sine wave. Look at that. Changing in frequency and everything. Okay, so let's increase the resolution here to be 1000. And let's increase the number of time steps to be 10. And let's just go to our Julia over here, include FFT animation. We're just going to run that. Mirage here. Okay. Yep, this looks good. Nice. Okay, so now we have our frequency changing. Literally all we need to do now is have a similar plot for, when we perform the FFT of our system, right? So now we can just do plot time, plot frequency. We'll have basically the same thing and it'll work from there. Let's see. Do you work with homogeneous coordinates? Build some DSP on FPGAs. LEL? I don't know what you mean by homogeneous coordinates here. I apologize for that. Xilinx chips with a combined FPGA and ARM CPU. Pretty cool. Yeah, again, I need to learn more about this. Let me go ahead and check to see something. So it is 7 o'clock, which is usually about the time that I end stream. And it looks like Tim is live. So what I might do is I might go ahead and create this plot frequency function. And then once we create the plot frequency function, I might call it a day because it'll take like 2 seconds to create this plot frequency function. And then we'll call it. So let's pop down here, open up something here, and we'll call it plot frequency here, and we'll do resolution here. So that's A, and what I want to do is plot abs 2 of FFT of A. All right, so we'll do the FFT of A. We'll do abs 2 of the FFT of A, but then I only want to plot a couple of these guys. So I want to plot from 1 to resolution over 2. Let's see if that works. So we're going to do plot time, and we're also going to do plot freak. And in a similar vein, we're just going to do 1010. And we'll modify this some more tomorrow, just to kind of get all the plots up and running. Okay, so we'll move over here, run include FFT animation.jl. Of course, it gives us a problem. No method matching abs2 of array float. What am I doing wrong then? What was it before? It was B is going to be equal to FFT of A. And then so B is equal to FFT of A. There's a dot there now. Okay, invalid index 1.0 of type float64. So I guess what I want to do is down here is do div of res here, syntax separated. Okay, and add that there. Okay, that one seemed to run. Let's take a look. Mirage time. So here is our plot. Okay, so that's our time plot. I screwed up in that I should have done rename this to frequency. Let's go here and let's just run Julia include whatever, yada yada. Pop over here, run Mirage. So here's our time plot. You can see the frequency is changing, and then we should see a frequency plot here. Okay, so here's a frequency spot. You can kind of sort of see that the frequency is increasing here, which is great, but we want it to increase by a lot more. So what I'm going to do is I'm going to modify some parameters in here. So I'm going to go in here and I'm going to increase the, I guess we'll say max frequency. Oops. Let's pop down here and multiply this by plus max frequency. I think I don't need this float 64 times I times time steps anymore. We'll see what happens. So I'm going to change this so the max frequency now is going to be 100. Let's go over here and let's just do Julia. Should work. And now we're just going to take a look at that image real quick. Mirage time. Yeah, so you can see the frequency is increasing by a lot more. So that's great. And let's just do the same thing over here. So we're going to add in a max frequency. Change this so it's now max frequency. There, remove this float 64 because again, I don't think it's necessary. And let's try this again. So we're going to run Julia, include FFT animation, and let's take a look. So we're going to pop over here, Mirage time. So here's our time domain. You can see it's clearly increasing. And then here's frequency. It's increasing by a bit more, but it's not quite there yet. So it should be increasing to about 50. So we'll keep working on this animation tomorrow. There's a lot left to be done. So on the one hand, we do have the animations kind of sort of working, so we're getting there. On the other hand, again, still a lot left to be done. Okay, the low-end ultra-scale chips are Cortex A53 plus FPGA logic, and soft of sort of affordable. Very powerful for some applications. The problem is if you stick with FPGA's manufacturing company, then you're more likely will earn money for them than sell something and earn money for yourself. Omega Thou, this is Julia. Yep, as they said. Okay, guys, so I think this is a good place to stop. I realize we didn't get too much done today, but we kind of figured out what we need to do, so I'm pretty happy with that. We're kind of going to be working on these animations tomorrow. There's a lot of animations left to be done for the FFT chapter, just a lot of them left to be done. We have to find a better geometric representation of what a butterfly diagram is. I need to kind of think about this. There's a lot of things to think about, but the hope is that we get the FFT chapter mostly done by the end of this weekend, so that we can start attacking like other things like fractals and stuff like that. I haven't decided yet if we're making a year-end Contributors Corner video. We'll kind of decide on that. I'll decide on that tomorrow. We'll see. I think today is Thursday, so I think I'll decide on it on Friday, and we'll see if we can get it out by this weekend. If not, we'll have a fractal video out on January 6th. Which is my goal for getting that video out. I think that is basically it for now. So I'm more looking into earning money for myself than for some guy in FPGA company who's controlling my production with his tools. They control essentially everything. Yeah, that kind of sucks. FPGA idea is cool, but the thing is they control the amount of blocks and slices in their hardware, really closed software and so on. Yeah, it does kind of suck. Okay, so again, we're working on the visualization. There's a lot left to do here. I'm sorry that I spent too long rambling today, but I promise we have a defined goal for tomorrow to work on these FFT visualizations, to really get some cool stuff working, and we're hoping that it'll all work out. I think that's it for the day, guys. Thank you so much for coming in. Have a great day, night, afternoon, morning, evening, whatever time it happens to be your time. I will see you again tomorrow when we work on the FFT revisions. Again, lots of stuff to do, but I'm pretty happy with the direction that we're heading here. And that is it. So thanks again, guys, and I will see you next time. Bye, guys.